Welcome to Maratha Vidya Prasarak Samajas, KRT Arts, BH Commerce and AM Science, KTHM College, Nasik. Myself, S.S.Demse, working as Associate Professor in Department of Electronic Science. Dear students, we already discussed the serial input-output in first lecture. So this is the second lecture for this topic. So continuation of this lecture. As we know, data communication is having two types: parallel data communication, serial data communication. Parallel we are not using for long distance communication, so we use serial communication. Serial communication having two types: synchronous and asynchronous. In synchronous communication, the clocks, transmitter and receiver should equal, but this is not possible for long distance, so we use asynchronous communication. In asynchronous communication does not use common clock are different, so baud rate to be same between transmitter and receiver for free communication. Baud rate means the bits per second. In 1 second how many bits are transmitted, so that is given by baud rate. 8051 microcontroller supports the baud rate and it needs the serial control special function registers like this. In 8051 microcontroller, serial communication of data is performed with the help of following special purpose registers. The first one is buffer register, second one is S.C.O.N serial control register, and T.Y.B.Sc register, T.C.O.N register. So we already discussed buffer register in detail. The serial control register, so this is the 8-bit register and its format is like this. It is a bit address register and used to set the modes which serial communication takes place in controller. So in above figure, this S.C.O.N 0 to S.C.O.N 7, so these bits are used for serial communication. The pin description is like this. Pin number here S.C.O.N point 0, that is S.C.O.N 0 is RI pin, receive interrupt flag. S.C.O.N 1, that is TI pin, transmit interrupt flag. S.C.O.N 2 RB8, receive 8-bit and 9-bit is reserved for a parity. S.C.O.N 3 TB8, the transmit 8-bit with 9th bit as a parity. S.C.O.N 5, that is SM2, serial port mode 2. S.C.O.N point 6, then that is serial port 1, SM1. S.C.O.N 7, then that bit is SM0, serial port mode 0. The serial control register supports the 4 different modes, and that is given by this serial port mode 0 bit and serial port mode 1 bit. When both are 00, mode 0 shift register, and the baud rate is oscillator frequency divided by 12. 01, that gives mode 1. In mode 1, 8-bit UART and the baud rate is variable and decided by timer. This mode mostly used in serial communication. 10, that gives us mode 2, 9th bit 9-bit UART, and the baud rate is decided by a crystal oscillator frequency divided by 32. 1 mode 3 9-bit UART mode. So these are the modes of serial communication decided by serial control register. Now these bits functions we already discussed in last lecture. We are focused on now mode. So what is mode 0? So in this mode 0, serial data are transmitted and received through RxD pin, while RxD pin output clock. The baud rate is fixed, and that is 1/12 oscillator frequency. So here this is the on-chip oscillator, that is crystal frequency, and that is divided by 12, and then that gives us baud rate. The serial port clock source is like this in mode 0. On transmit, the least significant bit LSB is sent or received first. The baud rate is fixed in mode 0. In mode 0, it is always on chip oscillator frequency divided by 12. The transmission and reception process is like this. Transmission, data transmitted is initiated by writing data to S buffer register. In fact, this process starts after any instruction being performed upon this register. When all 8 bits have been sent, the TI bit of S.C register automatically set. So in this way transmission take place. Reception take place like this. Data received through RxD pin and recognize when the following two conditions are met. That is, bit REN, that is receiver enable, is equal to 1 and receiver interrupt is equal to 0. When all 8 bits have been received, the RI bit of S.C register is automatically set, indicated that 1 byte receive is complete. Since there is no start and stop bit or any other bit except data sent from the buffer register is in pulse sequence. This mode is mainly used when distance between devices is short, noise is minimized, and operating speed is improved. So this is the mode 0. In mode 1, 10 bits are transmitted through TXD and received through RxD pin in the following manners. So a start bit always 0, information 8 bit LSB first, and stop bit, that is always 1. So 1 start, 1 stop, and 8 bit information, 10 bit transmitted. The start bit is only used to initiate the data received, while the stop bit is automatically returned to the RB8 bit of the S.C register. The baud rate is fixed in mode 0 and mode 3, but baud rate is in mode 1 and mode 3 are determined by the timer 1 overflow rate. How the transmission and reception take place in mode 1? Transmission, data transmitted is initiated by writing data in serial buffer register, and end of data transmission is initiated by setting TI bit of S.C register. Reception, the start bit logic 0 on the RxD pin received data serially, pin initiated data received, the following two conditions must be met, that is receiver enable should be 1 and receiver interrupt should be 0. Both of them are stored in SCON register. The RI bit is automatically set upon the data reception is completed. The baud rate is in this mode is determined by timer 1 overflow. So this is the baud rate, a clock source in mode 1 and mode 3. So this is the timer 1 overflow. When it is divided by 32, S mod will be 0, and when it is divided by 16, S mod is equal to 1, and that decides the baud rate. So baud rate will be variable in mode 1. In mode 2, 11 bit are transmitted through TXD pin and received through the RxD pin. 1 start bit always 0, 8 data bits LSB and programmable 9th bit data, and another one is stop bit, that is equal to 1. So like this the 11 bit information transmitted and received. On transmit, 9th bit data is actually in the TB8 bit of SCON register, and this bit is usually has a function of parity. On receiver, the 9th bit goes into RB8 bit of the same register SCON. The baud rate is either 1 by 32 or 1 by 16 of the oscillator frequency. Now how the transmission and reception process take place in mode 2. Transmission, data transmit is initiated by writing data to the buffer register, and end of transmission indicated by setting TI of SCON register. Reception, the start bit logic 0 on the RxD pin initiated data received, and the following two conditions should be met, that is bit REN is equal to 1 received enable and bit RI is equal to 0. Both of them are sorted in SCON register, and the RI bit is automatically set upon the data reception is completed. The serial port clock source for mode 2 is like this. So this is the crystal frequency, which is divided by 32 when T mod is equal to 1, baud rate decided, and this crystal frequency divided by 64 when serial mode is equal to 0, then the baud rate decided by this frequency clock in mode 2. In mode 3, so this is the mode 3 is same as mode 2 in all the respect except the baud rate. The baud rate in mode 3 is variable. In short, the parity bit is the P bit of program status word register. The simplest way to check the correctness of the received byte into odd or odd parity, add parity bit to it. Simply before initiating data transmit, the byte of transmit is stored in accumulator and the parity bit goes into TB8 bit in order to be a part of the message. The procedure is to opposite on received byte is stored in accumulator and the parity bit compared with the RB8 bit. if there are no variations in data received is correct. So this is mode 3. Now timer mode register, which we already discussed in timer and clock. This is a revision of that register, special function register. It is 8-bit register. Timer 0 and timer 1 set the various mode, timer mode using this register. Lower nibble reserved for timer 0, upper nibble reserved for timer 1, and this gate decide the external clock when gate is equal to 1. When it is 0, then crystal internal clock. C/T bar for this timer 1 and timer 0. When it is equal to 1, counter, and when it is equal to 0, then timer. So M0 and M1 mode select pins. Both are 00 mode 0 for timer 0 and timer 1. 13-bit timer mode. 01 1 16-bit timer mode. 10 mode 2 8-bit auto reload. In our serial communication, this mode we use for baud rate selections. So we are going to focus on this 1 mode 3 split timer mode. To find the values of T-mod register to operate in the timer in mode 2, timer 1 and timer 0 is like this. So as we know, this timer register, when we want to use timer 1 in mode 2, then this bit will be 8-bit auto reload mode, and C/T bar is equal to 0, gate is also 0. So this gives us a 2 decimal value or hexadecimal value. The remaining bits are 00, so this will be 0. 20 is the value loaded in T-mod register to keep timer in mode 2. Similarly, if we use timer 0 in mode 2, then the bit will be, all these bits are 0 because we are not using timer 1 in auto mode selections. So 01, that gives us value 2, and therefore the T-mod register loads 02H for timer 2 in mode 2. So this is the difference between this value. So timer 1 in mode 2 20, timer 0 in mode 2 is 02. That is loaded in T-mod register. The concept of baud rate generation in 8051 microcontroller. So how the baud rate is decided? Now this is a circuit block diagram of this, and that gives us the crystal frequency divided by 12, that gives us machine cycle frequency 921.6 kilohertz, and it is again divided by 32, that is for serial universal asynchronous receiver and transmitter. It is divided by 32, means it gives us this 921.6 kilohertz divided by 32, that gives us 28,800 hertz frequency for timer. Now this table indicates the baud rate, the value of TH1 register in decimal and in hexadecimal. So why we divide this, or why this baud rate is chosen? Because of baud rate supports by the Pentium and IBM PC are like this. So that this is for lower version and this is for higher version microcontroller. 1200 baud, 2400, 4800, 9600. So like this baud rate will be decided by putting the values of TH decimal -3, -6, -12, -24, and hexadecimal FD, FA, F4 and E8 for these baud rates. Now let us find how it is determined. As we know, TH having a maximum count value FF, so if we minus it by 0.3, so that gives us FD, minus 6 FA, minus 12 means F0C in hexadecimal, so F4 will be the value loaded in TH. If it is a baud rate is 1200, then FF minus this 24 decimal in hexadecimal 18H, so this minus gives us E8H value loaded in TH1. So how to find the baud rate? What are the different steps taken? So that is given in this example. With crystal frequency 11.059 megahertz, find the value of TH needed to have the baud rate 9600, so A part, and B part baud rate 2400. So solution for this is a crystal frequency 11.0592 megahertz. In first step, machine cycle frequency of 8051 determined, that is this crystal frequency divided by 12, so that will be 921.6 kilohertz. In step 2, frequency divided by UART, so that is for a timer, so that frequency, so this is machine frequency divided by 32, that gives us 28,800 hertz. So to find the baud rate of 9600 timer 1 value, we can calculate it like this. In step 3, set the baud rate of 9600 value to be loaded in TH count is 28,800 divided by this baud rate value, that is 9600 is equal to 3. So this is a decimal value. So this decimal value converted into negative answer, in that is minus 3, and this minus 3 is the decimal value. So to convert this value into hexadecimal, the fifth steps we take, use decimal value of TH is minus 3, means 0 minus 3, that is equal to minus 3. Take this as 0, 3, 0 indicates minus and 3 indicates the value. So 0 means 0, 0, 0, 0, 4, 0, 0, 0, 1, 1, that is 3. Take the 2's complement of this number. So 2's complement of the number means 1's complement plus 1, and it is like this. So this is the number 03, is 1's complement is 111, 1100. 1 is added, so this is your 2's complement. So 111, 1101, that is having the EFD value in hexadecimal. So this value is loaded in TH1 for the baud rate 9600. So this is first A's answer. The second B is common up to step 2, and the step 3 will be different. To set the baud rate of 2400, the value is loaded in TH count is like this. We take this frequency provided by UART, that is 28,800 divided by 2,400, that gives us a 12 answer. So this 12 decimal number is a TH value, which is always negative. So that minus 12 will be loaded in TH decimal, but hexadecimal value we have to determine. So in step 5, decimal value of TH1 is minus 12, means 0 minus 12 minus 12. 0 C is the hexadecimal value. So in binary 0 0 0 0 1 1 0 0. So 2's complement of this number will be the hexadecimal value. So that will be 0 0 0 4 0 4 1 and 1 1 0 0 0 0 1 1. 1's complement plus 1. So that gives us the values, that is 1 1 1 means F, 0 1 0 0 means 4. So 4F hexadecimal value loaded in TH for the baud rate 2400. So TH is equal to F4H. So in this way we can determine the value of TH. So there is reflection questions. Why the timer 1 is used in mode 2, that is 8-bit auto reload mode only. 30 seconds for these questions. I will wait. Try to give this answer of these questions. Now the answer of this question is, as the mode 2 is auto reload mode, once the baud value is set, it will be maintained throughout the duration of data transmission and reception are same. That is why this mode is used. Now increasing the baud rate. The baud rate can be increased by two ways. First way is increasing the frequency of crystal. Second one is change the bit picon register. So this is a way of increasing the baud rate. Crystal frequency we cannot change, so using picon register, power control register, the baud rate can be double. So it is like this. Picon register, it is 8-bit register, and its structure format is like this, D0 to D7. So we have to focus on this S mod bit, that is a D7 bit. When 8051 is powered up, the mode select, that is S mod, is 1. By setting S mod, the baud rate can be double. So when this bit is set, then baud rate will be double. If S mod is equal to 0, which is its value on reset, the baud rate is 1 by 64, the oscillator frequency. And if S mod is equal to 1, the baud rate is 1 divided by 32, oscillator frequency. So the diagram is like this. Crystal frequency divided by 12, that is machine cycle. This machine cycle frequency gives the baud rate like this. When S mod bit is equal to, this bit is equal to 0, then this frequency divided by 32. And when S mod is equal to 1, this frequency divided by 64. So this gives us the value, that is crystal frequency 28,800 Hertz, and here 57,600 Hertz. So this is provided to timer 1 to set the baud rate using TH, higher byte of timer 1. The comparison of baud rate. If we load the TH value -3, then baud rate will be 9600, and this is the hexadecimal value. When S mod is equal to 0 and when it is set is equal to 1, this get double, 19200. If we load the decimal value in TH1 -6, then the baud rate is 4800. So hexadecimal value is FA. S mod is equal to 0, then this, and when S mod is equal to 1, it get doubles. This -12 is loaded in TH, that decide the baud rate 2400. This is the hexadecimal value which is in EH. When S mod is equal to 0, this baud, and when it is 1, it doubles 4800. -24, the value loaded in TH, then that time baud rate is 1200. Hexadecimal value is this, and when T mod becomes 1, it is done. So in this way, by using Pcon register S mod flag bit, the value of baud rate get double. So thank you for listening. If you have any questions, contact on my mail ID S.S.Demse57@gmail.com. My WhatsApp number is 9860 389 302.